In this video, we're going to learn how to make this 3D printed bird feeder from start to finish. To get started with this project, we will need a couple of resources in order to make this project work. The first thing you need is a set of suction cups. I'll be using these suction cups which I purchased on Amazon. These are fairly inexpensive and it doesn't matter which size you use as long as it's big enough to fit securely on any window. The next thing you would need is a set of calipers as we will be using this to get the dimensions of our suction cups and to use that and reference that when we're designing our project within Fusion 360. The last thing you will need is a pen and notebook as we'll be jotting down details for our suction cup and then using the dimensions that we've taken from our calipers and then use that within Fusion 360. Once you have those three things in hand, let's go ahead and jump right into it and get started. Okay, so to get started with this design, the first thing we need to do is take the measurements of this suction cup here. Now, the main measurements we are going to take for this design is this back piece here. So bear with me because my camera might go in and out of focus several times for this. But the key thing we want to measure here is this back piece. This here is the piece that's going to connect into our 3D print, and we want this to mount on the back piece. So to do that, what we need to do is take the measurements for this largest piece here. I'm going to go ahead and name this the puck. Then we need to take the thickness of the bridge here where my pen is pointing to, and as well as from the front piece of the suction cup all the way to the puck at the top. So basically from this top and bottom piece, then the thickness, and then the puck. Those are three measurements we're going to take, and we're going to use our notebook down below to write out those measurements. So with that said, I'm going to go ahead and jot down the names for the measurements we're going to take, and then we'll go ahead and get started. Okay, so here in my notebook, I wrote down a couple of things. We have the bridge thickness, the bridge length, and then the puck. So with that said, let's go ahead and use our calipers and get started with setting up some dimensions here. So from here, what I'm going to do is just take my suction cup, reset my calipers all the way to 0, making sure we're at a fresh starting point, and then using the largest jaws on my caliper, opening these up, and then just positioning them right into the blades of our jaws here. And what I'm going to do is just make sure that the bridge thickness here, this is the bridge thickness in between the middle, I'm going to get the measurements for this. And I'm just going to do my very best not to squish this thing here because this thing is kind of a softer material. So it's very easily squished and you don't want to tighten it too much because then you're going to get a wrong number. So I'm going to go ahead and reset this from 0, open this up, close it back down. And as you can see, the dimensions here are 6.31 millimeters. Just going to give it a little bit of wiggle room just to make sure. So 6.35, that's like the common trend here. Just wiggling it around, just making sure. And just making sure I'm not squishing it. So 6.3, that's kind of like the general area that we're working with. So now that I got the thickness of the bridge here, I'm gonna go ahead and write this down on my notebook. The next thing I want to do is take the bridge length. So we need to go ahead and get the dimensions for this. But how do we do this with this front piece? Well, we can't do it with these larger jaws. We need to use the back side here. So let's go ahead and reset this to 0. Make sure it's zeroed out. And then going ahead and just moving this out until our inner jaws on the backhand side kind of meet towards the middle here, making sure it doesn't extend the silicone or the rubber of this piece here. So I'm getting a dimension reading of 2.9 millimeters, and I'm also going to wiggle this around just to make sure. So 2.9 seems to be the length of this bridge here. So I'm gonna go ahead and jot down 2.9 millimeters on my notebook. So now with that done, the last thing we need to cover is get the dimensions for this puck here on the top of this thing here. So to do that, I'm gonna take my calipers, reset it to 0, then opening up the largest jaws on my calipers, and then taking the thickness of the puck here, and let's see what the reading is. And the reading here is 10.53, just making sure it's accurate. And that looks good to me. So I'm gonna go ahead and jot these measurements down. And from here in my notebook, I have a couple of measurements. So with these measurements here, I can go ahead and figure out what the clearances are for my design when we start designing within Fusion. We know that the thickness of the bridge is 6.3 millimeters. We know that the bridge length is 2.9, and we know that the puck is 10.5 millimeters. Now, knowing how 3D printing works, there's usually a clearance that you want to leave that's usually anywhere between 0.12 millimeters or 0.24. Anywhere between that range will work just fine. The lower it is, the tighter the fit. So now with the dimensions written down, what we want to do is use these dimensions within Fusion 360 to start setting up the back pieces for our design here. So as of right now, we're not going to use this until we get started with our design, but we'll be using this later on as we start sketching our product. So with that said, let's go ahead and jump right into Fusion and start creating our product. Okay, so here I am within Fusion 360. Additionally, I also have my notebook right in front of me just in case I need to reference these dimensions later on. And I always have this in front of me as I design because it's incredibly important to have these values. So when you get to that point in time, you'll always have them in hand and use them when you want to create your design. So to get started, what we want to do is open up a blank new canvas within Fusion 360. From here, let's hover over to Create, New Components, and let's go ahead and name this to bird feeder and press OK. I'm also going to create another component by clicking on the unsaved component here, clicking on Create, New Components, and I'm going to go ahead and name this to Nest. This is where our food or water is going to go into, and this is the removable piece that comes outside of our bird feeder. Press OK. From here, I'm going to go ahead and toggle on bird feeder, which is what we're going to start designing on, and then we can go ahead and start designing our product. From here, let's click on Create Sketch, then selecting the bottom plane. And what we want to do is to create a center rectangle. To do that, click on Create, Rectangle, Center Rectangle, and then from the origin, drag this out. I'm going to set the length of this to around 150 millimeters, and then I'm going to set the height to this to around 90. Press Enter. From here, pressing O on our keyboard, selecting the outer line here, and I'm going to set the offset here to around 2 millimeters. The reason I did this is because we're basically using these 2 millimeters as the thickness for our walls here for our design. Once that's done, press OK. And using this newly created profile, let's go ahead and select that profile, press E on our keyboard, and let's go ahead and extrude this up by around 50 millimeters. Press OK. From here, what I'm going to do is create another sketch, creating the front cover that sits in the very front of our bird feeder. Clicking on Create Sketch, then selecting the top face here, then creating a 2-point rectangle from the bottom here all the way to the right hand side. I'm going to set the height of this thing to around, let's just say 25 millimeters, and then make sure it matches up to the right hand side. I'm probably going to make this a little higher, maybe to around 32. And that looks good to me, making sure that the 2-point rectangle reaches all the way to the very end, which is at this right hand side, and you'll see it match up with this little icon appearing here on screen. Once that's done, I'm going to select this profile here, pressing E on our keyboard, and then just dragging this down by around -2 millimeters, making sure that this is being dragged down and setting the operation to join, and press OK. With that done, we can go ahead and create the back part for our design. So let's go ahead and reorient to the back, and let's go ahead and get a better look by zooming in. And then what we need to do is reference these dimensions that we use to get the dimensions for our suction cup, and then use that for our design here. So to get started with this design, what I'm going to do is I'm going to toggle off my components and turn off all the sketches for this here. That way we don't accidentally select the wrong one. From here, let's click on Create Sketch, then select this back face here. And then what we want to do is create a line from here to here. To do that, press L on your keyboard, start from this edge here on the left-hand side to the right, and make sure these are dimensioned, and you'll see that they're dimensioned when they have a black dot here. Let's go ahead and press D on our keyboard, select the line here and the edge here, and set the degrees here to 45. I'm also going to set the distance from this dot to this line here. This is going to be above, or more specifically, it has to be higher than 10.5 millimeters in order to make sure our puck fits. So I'm going to set this to around 12 millimeters. That way there's enough space for our puck to fit in. The next thing we need to do here is to create a center diameter circle. Then from the center here, I'm just going to drag this out. Now with our bridge thickness and our bridge length, we can go ahead and set up the right dimensions for this. Now with 3D printing, there's usually some level of clearance that you need to create in order for our print to fit in with the suction cups that we're going to make. So the bridge thickness is 6.3 millimeters. And if we were to set this up at 6.3 and print it, it would print just fine, but it's very likely our puck or our bridge here would not fit into it. So what we need to do is add a little bit of clearance. I'm gonna go ahead and press plus on my keyboard and add a clearance of 0.2 millimeters. That means our total dimensional size of this piece here is 6.5. giving it around 0.2 millimeters of clearance for it to fit in to this diameter circle here. Let's go ahead and create 2 lines from the circle going all the way to this piece here, and then making sure that these lines are tangent to the circle. Selecting this line and then this line to this circle. And then what I'm gonna do is set the dimensions for the circle to the left and as well as the top. From the left, I'm gonna set this to around 6.5. And then from the top, making sure that matches up as well. Now with these dimensions in place, I can go ahead and finish sketch, then select this profile, press E, and now what we want to do is make sure we set up the bridge length to be just thin enough for it to fit in the bridge. So if our bridge length is 2.9 millimeters, what I'm going to do is make sure that there is actually, the bridge here is actually thinner than the bridge length in order to fit in. So it's actually going to be negative 2.9 millimeters only because we want this to go the other way. And then what we want to do is add negative, I'm a parentheses there's, negative 0.2 millimeters. And actually, let me just subtract that instead. So our distance here is going to be 2.7 instead of 2.9. So just the same way we created a 0.2 millimeters clearance for our circle here, we're also going to do the same thing here. Once that's done, press OK. With that done, we can turn off our sketch. Then let's go ahead and reorient this to the other side. And now we have our layout for our puck holder here. Next, we want to go ahead and create a chamfer here, pressing S, type in chamfer. We can select this edge and just chamfer this in to around 2.5 millimeters. Press OK. The next thing we want to do is to mirror all these features that we just created onto the right-hand side. To do that, press S, type in mirror, then selecting the features relevant to creating that part there, which is the last 2 within our timeline, selecting the mirror plane, then selecting the middle plane here, and then mirroring that to the other side. Now you have 2 cutouts for our suction cups here, one on the left and one on the right. Additionally, if you want to go ahead and print this out and give it a quick test, feel free to do so. I already went ahead and printed this out, and this is how they fit into it. To also add some of these at the bottom, I'm going to press S on my keyboard, type in mirror, then selecting the last 3 features which created these top 2, selecting the mirror plane, selecting the bottom, and press OK. From here, what I'm going to do now is to create the cutout or the opening for our nest at the bottom. To do that, I'm going to go ahead and use the section analysis. Section analysis tool within Fusion, pressing S, type in section analysis, then selecting one side and just dragging it in so that way we get a clear cutout of our design. Press enter. From here, click on create sketch, select this face here, and then creating a 2-point rectangle from the very top here at the very corner all the way to the bottom here. Pressing E on our keyboard, selecting this line here or that face there, and just dragging it out. That way we create a cutout. The next thing we want to do here is to hover over to the right-hand side or the left-hand side, then clicking on nest, and then turning off on our analysis since we won't be needing that any longer. Now what we want to do is using that newly created cutout here, we're going to go ahead and create the nest. This is the part or piece that's going to hold the food or any water you want to add for this bird feeder. To do that, press O on your keyboard, select this front face here, and let's go ahead and select this edge here and drag this into around, let's just say 0.24 millimeters. So I already went ahead and added a clearance of 0.2 on our design, but you can also add a 0.24 clearance. That way it gives it a little bit of extra wiggle room to create your design here. Press enter. Next, we can select this profile, press E, and then drag it out to the other side. I'm going to make sure this is set to negative 1.2 millimeters and making sure the operation is set to new body and press OK. Now, as you may have noticed, you can see that our suction cups here will fit in this piece here, but our nest is currently cutting into it. Now, if you want to use these suction pieces here, what you would have to do is just go ahead and go back to your sketch 1, press L on your keyboard, and create a little bit of a distance here so that way we can actually fit in our puck here at the top while giving our nest a place for it to fit into. So for example, if I were to remove this piece here at the top, just untoggle the profile at the top, and that way there's a little bit of space in between here and here at the top. Additionally, since we didn't measure the thickness of our puck, or more specifically the height of it, we don't know what the dimensions are here, but you can go ahead and do that if you really care about that. I'm not going to go ahead and add suction cups here at the bottom. I'm only going to add them at the top, as I went ahead and already added them to the top, tested them out, and they actually work just fine, even with these two just sitting here. If you want to add some sort of adhesive at the bottom or use adhesives instead, then you can pretty much just add any sort of line or a profile here and extrude it. That way you can have this nest fit in while having something here to hold the adhesive. But with that said, I'm going to go ahead and continue this design. Next, I'm going to go ahead and press S, type in shell, select this front face, and shell this into around 2 millimeters. Press OK. Next, I'm going to create a sketch, then select this face here, making sure we're selecting the nest face and not this face here. I'm going to create a 2-point rectangle from this edge here at the very tip of this design here, and making sure we're selecting the right item. And if it doesn't select or hover over, let's go ahead and redo this. Create sketch, select this face, then creating a 2-point rectangle from the very top, create sketch, select this face here, then selecting 2-point rectangle from the edge all the way to the bottom. Then I'm going to set the distance here from this line to this line here. Set this to around 10 millimeters. Pressing E on our keyboard, selecting this newly created profile. I'm going to go ahead and extrude this out to around 10 millimeters as well, and press join. Next, I'm going to press S, type in shell, select this inner body or inner face here, and type in 2 millimeters, and press OK. Next, I'm going to press S, type in chamfer, create the chamfer here so that way this pulls out from this edge to this edge, and just drag this out so that way we don't need supports for our design here. And there you go. Now, if we turn on our original component or the top level component, and then reorient this so we can get a better look, turn off all the sketches. Now we have our 3D printable bird feeder fully designed within Fusion 360 with enough wiggle room for our pucks here to fit in, and as well as for the bottom. And just to give you an example of what this would look like, so if we were to reorient this, this is the bird feeder mounted to the window. This piece here at the bottom moves out, allows you to put in food into this, allows you to slide it back in, and that way it's easy cleanup without having to remove this bird feeder off of your window. So with all that said, what I'm going to do is add a couple of more design details. To do that, I'm going to go ahead and click on bird feeder, then press F on our keyboard. Let's add some fillets, selecting this top edge on the top and left hand side. Then underneath, making sure we're selecting the lines underneath as well, and then just dragging this in. I'm going to set this to around 4 millimeters and doing the exact same thing for this line here, this inner edge shown here, giving it a nice rounded TV look. And you can also add some here at the bottom if you want to, totally up to you, but I'm happy with this design and way it came out, so press OK. And then from here, we pretty much have our 3D printable bird feeder designed within Fusion 360. I'm going to press A on my keyboard. Let's go ahead and add some color, then setting it to plastic matte yellow, which is what I'm going to be using to print this design, and applying it to both icons or items here. Next, let's go ahead and export this to our slicer and set up the supports for this design. Okay, so here we are within Bamboo Slicer. I'm going to go ahead and reorient this so that way we have the front face actually facing down, and then going ahead and setting up supports for this design. Now, this design only needs supports in a couple of areas, which is the 4 pieces or 4 parts here from left to right. I'm going to go ahead and set up manual supports and paint this around. So selecting the bottom edges here and selecting all 4 sides. From here, I'm going to set the supports to normal to tree, which is tree manual, then setting the style to tree strong, and making sure that the supports don't actually sit on this face here. It actually sits on the build plate here. Setting this to build plate only, slicing plate, and now we have our supports fully embedded into our design, giving us a nice clean support structure while supporting all the areas that do need this. And especially since this piece sits on the inside, meaning that the supports or the support removals aren't really visible from the user perspective, it makes it a nice, easy, and clean removal without having to see any sort of weird areas where it's patchy or anything like that because of the supports. So with that said, you can also go ahead and export the nest for the bottom, save as mesh, and then taking these 2 designs, reorient them. That way they're ready to go. And here is our 3D printable bird feeder from start to finish, complete with supports, ready to be 3D printed. And I'm going to go ahead and 3D print this out and show you what the final results look like. Okay, so here we have our fully 3D printed bird feeder from start to finish. On the back side, we have the suction cups mounted onto the top pieces here, and then we have the sliding door at the bottom, so that way we can actually restock the food for the birds. This is a great simple project, especially if you're a complete beginner and you want to learn how to create your own functional designs that also incorporate other products or designs or elements that you typically wouldn't 3D print. I went ahead and mounted this to my window, and I think it came out great. And I think this would be a great addition to the garden that we have here, especially since summer is rolling around and I know that we have a lot of wildlife within the area. But with that said, if you guys enjoyed today's video, make sure to like and subscribe down below. If you want to get access to more tutorials just like this with more in-depth training and as well as community support when you get stuck, need help, or need your questions answered, I'm hosting the 14-day design challenge showing you exactly how to design your own models from start to finish, and as well as giving you access to my entire catalog of STL files. So if you want to get access to this challenge and surround yourself with other people also creating their own models and designs, I'm gonna leave a link down below to sign up. Feel free to join anytime. And with that said, I look forward to seeing you inside that group. Take care.